All right,
Uh,
should be good.
okay. So, welcome everyone to today's training, and that focuses on the troubleshooting on the OSPool. And before we go into that, just a brief introductions of our team. Uh, so I'm Shomek. My background is on the mechanical engineering, and I work with UNL and also part of OSG. And my colleagues, Christina and Andrew, are here today with me. They are both located at EW Medicine, and Christina is our research facilitation team lead. Andrew's background is in the chemistry, and Christian's background is in mathematics. And also two other of my colleagues, Amber and Mars. Amber is based on medicine, and I believe her background is also on the chemistry side. And Mars is on the USC, and his background is on the computer science side. So if you don't know us already, like, yeah, this is our information and our geographical location. And as like any of the trainings, yeah, if you have any questions, yeah, feel free to mic up, or as I mentioned, that I have my chat window open. So whatever questions that you may have, feel free to post them on the chat. We'll be monitoring the chat throughout the training process. And I do have at the very end, so I do have a demo portion. If time allows, like we'll go through on the demo side, but the slides or the training would have much more information, and uh, all of you have links to the slides. And this slide was, I should mention, previously developed by Andrew. I just made some minor modifications to that slide, and it contains very good information. So after the training is done, like you'll please to keep the link handy. So if you have any issues or anything, any information that you need to know or that you need to catch up, the slide would be the number one tool for you to go through. And a brief overview of the learning objectives for today. So today we'll be looking at what are the job issues with the job submission that can happen when you're submitting your jobs on the Open Science Pool. And most of you are already familiar with some of the issues, like your jobs may go on hold, your jobs may take some time to start, uh, you are not finding resources. So we'll go through all of those things. And yeah, the two outcomes that you'll be mostly focusing on, yeah, what can go wrong, and the tools to diagnose those issues or the problems. So first, to identify the cause of the problem. Before you're submitting a job onto the OSPool, you should have a good idea about like what you are trying to do or what you uh, hope your code would achieve versus what actually happens or what actually happened in your workflow. And uh, as I mentioned, like hopefully you should have a very good idea that the things that you want to do, but you should examine your .sub file or the submit file and see that whether you have your executable and have an idea like what type of data transfers that are involved in your in the calculations that you're trying to run, what type of folder arrangements that you have, and what type of softwares and commands that you're using. All of them are in the expected directory that you submit, that you are planning to submit it from. And to find out more like what happens or what happened when during your workflow, like the commands that you can use, the basic commands that I hope you all are familiar with is the condur queue, condur history, and look at the log files, error and out files. So condur queue would give you information about the jobs that are currently in the queue. Condur history would give you information about the jobs that are done, and you can find detailed information about all of those jobs that have been finished. It doesn't store it doesn't store up to like it has some time. I shouldn't say time window, like the number of jobs that it keeps on the record. Like if you're trying to access your jobs data within 1 or 2 days, then yeah, it should be there. And the error and log files, error out and the log files would contain informations about whatever your executable is generating or going through. Yeah, you'll find information over there. And yeah, at any point in time, yeah, feel free to interrupt me or ask me any questions. So moving forward, the 4 type of issues that we'll be going through in this training would be like, yeah, what happens or when your job goes on hold, and apart from the hold cases, like say your job completed, but your job wasn't successful, or the job result doesn't is not up to your expectation. Your job doesn't start, like it's taking some time, it's sitting idle in the queue. So how do you know like whether it would start at some points, or what are the things that you can do? We'll go over through that as well. And finally, that your job is running, but it's taking way longer than expected. So we'll go over and touch all of those issues. So firstly, we'll come to the issues of the job. Your job goes on hold. And before we go into the details of how to diagnose, like just a brief overview of how or when your job goes on hold. So HT Condor, the scheduler program that we have, which is managing everything, it's handles everything from your data transfer, running your calculations over the execution point, and then bringing you back the output file. So it has all those processes involved into a job, into the life cycle of a job. So if something goes wrong into that process, like logistical process of transferring, running of the file, like files are not in the same similar directory or in a directory that you specified in a job submit file, then HT Condor would put the job on hold. And it gives you a reason for that. So you can take a look, like if your jobs goes, if you have some hold jobs, the command that you can use would be condor_q space, then dash hold. And you would see a brief message that the reason behind your jobs going on hold. And apart from the command line tool, you can also, if you look at the log file of your jobs, you'll also find the information, what went wrong in your jobs lifecycle. And this is just to put you or give you a brief overview of what is involved in running a jobs on the OSPool side. So whenever you're submitting a jobs on the access point, your calculations are not running on the access point. It's running on a machine that we call as an execute point. So HT Condor on the job submit file, you define everything, your required file, your input file, your executable. And based on that, HT Condor grabs the files and folders from the directory that you specified, and it transferred them into the scratch directory of the execute point. And then HT Condor starts executing your executable, and every execution is happening over here. And if you have your output data, your logger and output file, then it gets sent back to your job submission folder. So if you have any error in transferring input files, if the error happens in transferring output files, like your code doesn't produce the output that you define, or there's any typo, your job would go on hold. So these are the things. Right side is the cartoon, and left side is the things that explain in details in terms of the purpose category. Like if you have any data transfer failure, your job is using too much memory or disk or usage, like your job is going over the resources that you specified in your job submit file. And yeah, if it has any issues with the container or your softwares, with the execution, your jobs would go on hold. And moving forward, like what type of messages that you can expect that you'd be seeing. We just have an example type of example message. You're saying that transfer output files failure at the execution point while sending files to the access point. So just from this whole message, we get an idea. I am not even reading on those sides. Like the error happened, like from the first line, I can decode that the error happened when your job ran and it HT Condor tried to send the output back to you. So The details you'll find on the next line. The details is saying that the some directory where you have the file, it cannot find any file or directory. So what may have happened? Like your code may have run on the execution point, but it didn't produce the output file. Or if you have the output file name, the name of the output file that you have, the output file that was produced, it didn't match. And me so file didn't exist, or it doesn't exist on the AP, on the execution point where your calculation was running, or the directory that you mentioned, the path that you had on your job submit file for the transfer output files, the file was produced on different directory. So HT Condor couldn't find the file. Or as the common error that we also see, the submit file has some typo into the transfer output files, either in the name or in the path. So I'll briefly pause here for a minute and just to check, like if you guys have any questions, any comments on the page, anything that needs to be more, clarified. Like I'm expecting that, yeah, you have a very big, good idea about the job submission process or the commands like Condor Q, Condor Submit. So if you have any comments or any issues with the pacing of the way that I'm going, yeah, do let me know. So I'll just pause for 1 minute and then afterward I'll move forward. Yes, Joseph, please go ahead.
My question has to do with relative file paths. It seems like when we submit jobs, the home directory gets put into some Condor directory and
Yes.
not ours. And so if we don't specify, should we always specify a fully qualified path and use the environment variable Condor Scratcher, I think it's called for us? Or can we use a relative path? Where do we end up with?
So I'd say like for our system, always use the relative path. And is your calculation error code like you are producing some files within?
I gotta say that I haven't started using the OSPool yet. I'm using our local Condor pool, and I'm here to learn, not to debug.
Yeah, so by default, the easiest solution I would say, like for our system, always use the relative path. The absolute path doesn't work. And for the like you don't have to do like $scratch like the using the environmental variable unless your code has some specific needs, like you are producing some files in time folder or other folders, then that might be a different issue. But on a overall basis, I would say like as a rule of thumb, just the relative path would work fine, should work fine.
Yeah. I would say I would use Condor Scratcher, like Shomik said, if if you're setting the path variable in the job, that always has to be a full path. So that's when I would use the Scratcher variable. But in general, it shouldn't matter which you use on the execution point.
Thank you.
Welcome. Yeah, thank you for the question. So I will move ahead and more onto the job hold side. Oh, excuse me. So even if your job goes on hold, like you could see, like it's having issues in the transferring output file, but the error may actually happen way earlier in your calculations life cycle. The transfer output file line, or when you have a transfer output file line in your job submit file, then it specifically looks for the file, the path and the file that you mentioned. But if your code doesn't execute properly, and it even if it just sorry, I should pause and then say, if your code's execution goes into any issues, then definitely you don't have the output file, or the output file won't be generated. And the message from the Condor side, you'll see that it had issues in terms of transferring your output files, but the actual issues may be with the code or scripts that you're using, as HT Condor puts the jobs on hold whenever it has any issues with the logistical side. So for finding those issues, like, yeah, you need to do some more debugging, and we'll provide you some information about that as we go along the training. Yeah. And as I mentioned, yeah, the files at the job state at the execution point, yeah, it's not saved when the job is on hold. And when the job is on hold, the job is stopped, and the slot or where the execution point where your calculations were running, yeah, it gets reset. So everything that were in there, it gets deleted like an incomplete job. And so that's the info about if your job goes on hold. But let's look for other infos, like if your job is finished, but the output or even it's your execution, you are considering that to be unsuccessful. And the success actually very depends on like what do you mean by how do you define your successful run. So typically the things that happen, like, yeah, your code didn't execute correctly, or it doesn't match your expectations, or the output files that you were expected your code to generate, like it didn't generate or return or transfer those output files. So for knowing or have an idea about or for debugging those type of issues, yeah, first you need to have a good understanding, or need to know like what actually went wrong. And for that, we'll provide you some basic information, some tools that you can use to know more about what actually went wrong. So one of the things that you can use as a rule of thumb is that instead of just having an execution or executing your script, having a file name, having echo the file or folder structures, that's a very useful debugging tools that you can use. So in this example, like before you're executing your command, if just have the folder directory, and after the command is executed, then look for the folder directory again and see that, yeah, whether your code is producing the file that you're expecting it to be. And if your script consists of like multiple of those commands, then yeah, you can have those things repeated multiple times. So that would help you in debugging the chunk of the code that's actually problematic. And even better, like if your code script has debugging or verbose logging, then yeah, please do enable that. In that way, in the log files or in your log in or out file, you'll find way more information to find out or to narrow down what actually is going on in your script, in your scripting. And another thing that you can use while your job is running on the execution point would be the control chart command. And it would send you information after each of the steps are done. It would directly send information back to the log directory, whatever command that you're after every command is done. Like if you're trying to figure out like your code has 3 or 4 steps that you are not sure out of the 4 or 5 steps which of the steps are going wrong, then you can use the control chart command to see like, yeah, whether each of the steps are executing properly or not. And as you have links to the slides, then yeah, we have links to the HTML documentation page embedded into the presentation. Yeah, feel free to go over them, and it has much more details about like the different modes, different options that you can use with control chart. So moving on to the third point, where you are submitting your job, but you are waiting in the queue for a long time, and you're trying to figure out like, is it some issues with your code, or is it the normal nature of HT Condor? So we'll talk more on like if your job doesn't start, then how do you can get some good idea, like whether it's an issue with your submit file or this is the nature of the pool right now that time that you submitted your job. So firstly, just to have some establish some ground rules in terms of like when you're submitting your job, it did take some time for the matchmaking process to go through. So as a rule of thumb, like for very small requirements, like yeah, do allow some 5 minutes or more. For small jobs, it usually gets way faster than that, like a minute or two if your resource requirements are lower. But if your resource requirements are higher, or you are requesting for some resources that are you are requesting for specific resources like GPUs, so those things are definitely going to be limited in the pool, and they are usually in the high demand. So it may be like someone else is using those resources and your jobs may have to wait. And if you request for more cores, higher memory, then same things, like there will be fewer slots that would match against your job resource request. So how would you know like the resources that you're requesting, whether they're busy or like we don't have that resources in the pool? So one command that's very useful is the condor queue dash better analyze. And this tool gives you an idea about the whole matchmaking process, like how many machines, like depending on your job resource request, like if you execute this command, and hopefully we'll get a time today to go over a demo where I can show you the better analyze command. And at the end of the output, like it will take some time to give you the output, but when the output is generated at the end, you'll see a table where in the table it will give you each of the category, like the resources that you requested versus how many slots were there based on that resource requirement. Like say you are requesting this many RAMs, how many slots are there that has that RAM capability, and if you are requesting for this, so you should sort out based on like cores, RAMs, disk space, GPUs, all of the things that you may ask in your job submit file. And if any of the cases you see that the matchmaking process, the table value gives you like 0, like there's no slots that has the capability right now, then you're getting an idea, like the resources that you're requesting, like, yeah, you probably don't need to tone down on your resource requirement side. And yeah, when we'll go through the demonstration side, like you'll get a good idea on like what the output actually looks like. I don't have the output in the slide, but yeah, I'll show you at the end, hopefully. And finally, the fourth point, that where your job is running, but you were expected your job to get done in an hour, but it's taking like way longer time, or it's not getting finished. So for this case, the first recommendation would be to see the log file, and in the log file see that whether there's any interruption, whether it's happening or the job is running continuously on the same slot, or there are interruptions and your job is getting kicked out from a slot and then it's starting on another slot, or your job is getting stuck on the file transfer step or in some certain step. So for the first case, like say your job has been running continuously on the same slot, that you expected your job to be run only for an hour, but instead it's running on the 24 hours. So the 1 hour expectation that you had, is it coming from that you have previously run your job in a cluster and you were asked for multiple cores where your job is running on a single core? And also the one thing that you need to keep in mind that the resources that we have, our resources are heterogeneous. So not all of the resources are brand new. So for your expectation wise, like if you expect your job to be finished on an hour, it may take 2 to 3 hours to be done on our system. But if it's like a way more mismatch, then something else may be going wrong. And for those cases, yeah, I would ask you to look for like previously, like the expectations of 1 hour for an example that you had, where you're getting that 1 hour expectation. And if everything matches, like, yeah, you have run the code previously with us asking for a single core with that much memory, then the thing that you need to look for would be like find that issues or problem with your code or software or like the machine that your code is running on. So in this slide, you'll get some tools that you can use to look for your running job. So one of the commands that you can use is contour tail. That would give you like the last amount of bytes that your job output. And we have linked to the manual page, and you can use that that has more details on how to use that command. Another one tool that is a bit tricky to use on our system right now at this point, like Condor SSH to job, where you get the ability to directly log into our execution slot. I wanted to delete this point from the slide, but I kept it because we do have some sites that gives you the ability to SSH into the job. But we don't have a job class add created for that yet. So this is something I believe that would be in development. But for now, I'd say like if you have any issues and you need to do Condor SSH to job in order to debug, then I'd say do reach out to us, and we'd be able to provide you to the site list of sites where you can run your test job and see that what are the issues that are going wrong or that's keeping your job running continuously. Any questions up to here? Oh, yes, Joseph, please go ahead.
Well, I don't mean to dominate the questions at all, but
Oh, no, please go ahead.
one of the tools that I use on our local clusters when a job doesn't run is to use Condor status and try and match what I think should match, and then do better analyze dash reverse. Can we do that on the pool?
So we do have the Condor status, and we'll talk about in the slide as well. But one issue with the Condor status that I should mention, like for our system, when you do the Condor status, it will just show you the resources that are currently in the pool. But our pool is dynamic, so the resources comes and goes. So say you are requesting for some resources, specific resources. When you submit the job, then the client or the pilot that works on the backend side, it would look to bring in more machines that may have the capability. So definitely that would help you in terms of getting an idea, but I would say do not make a concrete decision based on just the control status command. And
Yeah,
Andrew, if you
and
want, please go.
just to elaborate on that a bit more, Joseph, at our local pool, that's also something we do, is that better analyze reverse, matching the job with a machine we expect it to run on. But as Shomik was saying, the OSPool is a bit more complicated, a bit more dynamic. The machines, because they're opportunistic, they're institutions that are donating their idle resources to the pool. Um, what is available or idle at any given time can change at any given time on the OS pool. So it can make use of that feature a bit tricky to implement.
I could say that when I do use minus reverse, it more often than not points to my problem rather than a pool problem.
Yeah, so you can also match, you can do the quote unquote forward version. So if you provide the machine or that slot name and don't provide the reverse, you'll see what your job's requirements for the machine were and how they match up. So if you do with and without the reverse, that kind of gives you both sides of the story.
Thank you.
Shomek, I think Rahul had a question.
Oh, yes, Rahul, please go ahead.
Hey, Shomik. Yeah, so the jobs that I'm trying to run, has an added layer of complexity in the sense that I'm trying to read data from the OSDF. Now, sometimes I have been running into issues where um, the job is being held, and that's um, because it's experiencing slow data transfers from certain sites. Now, I don't know if this is a well-known issue because I've been observing this only since I think about past few weeks or maybe just last month. Um, is this something that that people needs to be aware of, or I'm also observing this only from certain sites. So from from the user side, can I prevent launching my jobs from these sites? I don't know what's the best strategy here.
Uh, so OSDF is a different beast, and the problem that you are facing, yeah, it's one of the common problems that sometimes people face with OSDF. Unfortunately, I don't think right now at this moment, like we have a fixed solutions in terms of like saying you like, yeah, just don't hit those caches. So the cache we do like when a cache goes bad or cache is getting slow in terms of data transfer, it gets marked down, but it takes some time to know that, yeah, this is the cache that where it's taking a lot of time. And for the HD control process to not to do matchmaking or not to use that cache for transferring data using OSDF. But in the meanwhile, like till the system knows that, yeah, not to use this cache, uh, your jobs may go on hold for those type of cases. And the quick solution, the only solution that at this point that I know on top of my head is to just release the jobs. Like if that's the only issues, like yeah, it's a slow transfer. And when you are releasing the job, they need to hopefully land on a different cache that doesn't have the slow issue. And Andrew would probably know more on that. Andrew, do you want to add anything to that?
Yeah. So in these situations that you described, ultimately that should result in a hold message. So the strategies we were talking about earlier for dealing with hold still apply. As for your question about, can you specify not to launch at those sites? Yes, that is possible. That being said, we would also like for you to notify us about it, because our us as the team that helps run the OS pool, you know, we rarely actually run jobs or at least run a lot of jobs on the OS pool. So some of these symptoms are ones that you, the active user, we rely on you to report them to us because otherwise we're going to assume the system's working fine. So, if you're able to notice or identify a specific site that seems to be causing these issues repeatedly, we'd really love for you just to shoot us an email, let us know, hey, I've been getting a lot of OSDF slow transfer holds on this site, and we can probably send you the how you can exclude that from your job, if as a workaround. And I'll say we are still trying to, and we are actively working to improve the OSDF experience on the OS pool, and you know, this sort of situation you describe is one that I would really like to get a handle on.
Yeah. Thank you so much for the questions. Yeah. And yeah, unfortunately, I don't have anything related to OSDF on this slide, but as Andrew mentioned, like, yeah, it goes onto the whole comment and we do have right now probably 2 or 3 types of issues that may happen on the OSDF side, but you'll see that on the whole message. Okay. So moving forward, the second point, when your job gets interrupted and restarted on another slot, and if it just happens once or twice, the common suggestions from our side would be like adjust your expectations of the runtime. And as I mentioned, like our hardware is heterogeneous. So yeah, some of the cases, like yeah, if you submit a batch of jobs, you'll see some tail end on the longer tail end side in terms of job completion time duration wise. But if it's happening many times, then the job runtime that you may have, it's maybe too long for our system. By default, the job runtime for our system is 20 hours, and the max that you can run would be 40 hours. And if your calculation always goes beyond that, then you have to either look for an option of checkpointing, or otherwise, if you cannot implement checkpointing, then probably those type of calculation is better suited for the HPC side, not for our system. But if you are sure that this is an HTC job and you need to have that, like we do have another set of hardware path facility where it may have the advantage of whatever your job runtime that you want, you'll have full control of that hardware and for that time duration. But in order to get access to that hardware, you'll have to have a NSF funding, or the PI needs to have a NSF funding. And we feel we can talk more about that after the training is done. If you need to know more information about that, and you don't know about path facility, yeah, please post your questions or on the chat. Now, finally, if your job is stuck on the file transfer step, so you'll see this information definitely on the log files that, yeah, it's trying to start, it has started transferring output files, and that's the last line. And also, if you do control Q-no batch, then yeah, you'll see either the arrows, and it means that, yeah, it's actually transferring the files. And this thing can happen like, yeah, if you're transferring a lot of files. So for any files that are greater than 1 GB in size per job wise, we easily recommend that you use OSDF so that the transfer process goes smoothly. And if you ever face into these issues, like I would say, like, do reach out to us and we may have a better session for you, depending on the type of data and files that you're using. And so that was the 4 types of generic problem. And we looked into like how we could identify and some tools that we can use. And now we are moving into some more generic terms. And excuse me. So overall for your workflow, find out the things like if you're going into those type of facing those type of issues, like for your whole code workflow or in your specific portion of your code, try to specify or try to find out the specific criteria or the cost that your code is not meeting up to your expectations. And based on that, yeah, change your implementation process. Like if your code is going for a longer time and you're requesting for a single core, then maybe it's not a single core job, then ask for probably a multiple cores. Or if the hardware, if your calculation needs to run on a hardware that has a faster, that is relatively newer, or that has a faster clock speed, then yeah, you do have the ability to implement that as well. Like if you add the flag like job duration category equal to long, and we do have this documented, then your jobs will be running only on the hardware that has a faster clock speed or that's relatively newer. And yeah, you may have to do some trial and error and to find a better solution that works best for our system. And as an example, we do have in the slide, we have a very basic example in terms of the TI. If we assume that your jobs is complete without errors and it would return the file output.csv that would have your process data or the data that you analyzed. And let's run through some of the scenarios. Like the scenario may be like your job completed, but you don't see the output.csv file. So the scenario one, the expected output file, it doesn't exist. It didn't exist on the execution point. Then you look for the error files and you see that it has a message like no module named numpy. So in the software or the execution side of thing, like on our system, as you mentioned, like, yeah, you need to use a container is the best way to go. So what are other packages that we need, like, yeah, to install everything in your container and use that container to execute your calculations. So you go into the software side, you modified your software, you create a new container so that it has the NumPy package, and then you test the job. Now it produces the output.csv file. So this is just a scenario-based example that the idea is to make you think about like, yeah, what are the things that you can do if your job has a critical step and you are not sure which of the step is going wrong. And also, whenever you are submitting a job, the dimensions of the jobs, yeah, or the failed jobs, yeah, you need to have that in mind as well. Like, how many of the jobs are failing? Like, is it just a very small percentage of some jobs that go fail? And yeah, what are the frequency? That is it like some of the jobs always fails, or is it like some random cases, like the scenario that Rahul mentioned, like if for WSDF issues, some random issues. For WSDF cases, sometimes it goes on hold. And also like where your job is going or failing, like is it failing on every machine or on a specific machine? So if it fails on a specific machine, then yeah, it's easier to find out the issues, or we can localize the error to be attributed to only that machine. And is it, yeah, the cause is it a systematic every time it's happening, or is it like a very transient? So for transient type of problem, most of the cases, as I mentioned, like in the OSDF error, it's best to just try again releasing the jobs. And for those cases, yeah, add some more debugging statement so that you can narrow down what are the issues that are actually going on. And for the systematic causes, yeah, we need to actually find the pattern of the errors or pattern of the issues that are happening. What do all of the failed jobs have in common? And how, or is it for some certain input that your jobs are going to fail? Like, is it the nature of the calculations or not? So those type of cases that, yeah, we need to identify. Okay, so yeah, you can use different ways to identify like some of the tools that we have gone through, some of the things that we have discussed to find those issues and information. But first, like, don't hesitate, I'd say, to reach out to us. And specifically, like when you have spent a good amount of time and troubleshooting and you don't have any progress, like we do have office hours twice a week, Tuesday, like right after this training at 3, and Thursday in Central Time at 10:30 a.m. And also like where to, like if you are using a code and you are not the only one from your group, who has the experience in using that code, then the first thing to go would be your colleagues or peers. In terms of your calculation side, we know more on the system side of things or how our system behaves, the HT counter issues, other things. But in terms of your calculations or code, you and your groups would be the expert. We do not, definitely, we won't be the expert on your scripting or your code. Look for Google and search for the, like if you have any specific message, like why does it happen? And yeah, as I mentioned, do reach out to us, and we do have office hours. And if it's on a probably like the last bullet point, I would say first, like you went to your colleagues, you looked for the solutions, and then you reached out to us. Then we'll talk with you and we'll probably determine like, yeah, whether this is something that needs to get the HT counter facilitators involved. So from your side of thing, I'd say like, yeah, the top three bullet points would mostly apply. And afterwards, would be a mutual discussion with you, us, and depending on that, we'll probably decide to go on to the next step or not.
Yeah, where that last bullet point comes in is if you're someone like Joseph who's running HT Condor at their local pool, because you know we don't we as OSG facilitators don't have any insight into the structure of your pool and how that may affect how things work, whereas the Condor developers are more used to asking those sorts of questions and dealing with those types of scenarios. I believe there's also like an HT Condor user list. I forget what it's called, but you can send questions to the HT Condor community there.
All right. Any questions? Yes, Joseph, go ahead.
I put one in the chat. Oh, I tried to put one in the chat, but I didn't hit return. When a job is vacated, like it overflowed its slot time or something high priority bumped it, are the intermediate files maintained when it's restarted? Because that's the way I tend to checkpoint. If this file exists, that step is done. Or should those intermediate results be classified as checkpoints? Does that make sense?
So I'll take a shot at that first, then I'll let Andrew answer. So if it's getting kicked out or counter vacate, then as far as I know, yeah, it doesn't keep anything in the memory. You won't have access to the files. But if you are creating some intermediate files, and for checkpointing wise, if your checkpointing step is done, then you'll get the files, like whatever checkpointed files that you had mentioned. It would be after the checkpointing step, it would be copied back to your access point, and you can use those files. Like if your job gets evicted, you can restart that job from that point.
Okay. Yeah, usually when when the job starts, it says how many of these intermediate files already exist, and that tells me where to start. So if I understood what you said correctly, I should have a periodic checkpoint and specify those intermediate files as my checkpoint files, or that directory as my checkpoint directory. Thank you. Makes sense.
Yeah. And so just to elaborate a little bit more in a general sense about this point, whenever a job goes on hold or is preempted or is vacated, whatever was going on in that job's working directory is going to disappear after the job leaves. There's some things you can do of, I think there's a keyword when to transfer output, and you can say that you want it to transfer on exit or evict, so that the job is evicted, it will still transfer the output. But in general, for whatever reason, maybe the machine is crashing, maybe the owner has decided it no longer wants to be part of the pool. But for some reason, when a job is held or vacated, something is inherently wrong and it's not going to be able to finish. And so instead of trying to preserve its state or its files or anything like that, it just Condor is going to consider that job as that attempt is unsuccessful and it needs to be returned to the queue so it can match make and find somewhere else to run.
I don't see any other things on the chat, so yeah, I'll just move forward. And some information about we mentioned about Condor queue, Condor history, but yeah, the class adds, we haven't specified that yet. So, oh yeah, thank you, Joseph, for posting that. So whenever you're submitting a job, your job gets a lot of attributes added to the jobs. And those are the we call as a class adds. So it has information about where it ran, how the memory assigned to the slots, machine details, all. It probably has like hundreds of thousands types of class adds. And you can view all of those things using the -l command, or which is short for the -long. And also the other way to use this command would be like, if you know like this thing that you are looking for, the HTML documentation would have details about all the class adds that are available. You can grab that, and also you can use layers, or like this. Most of the class adds would actually, some of the things would actually make sense, like in terms of like if you want to know about something about the machine, or say wall time or time, so you can just control q -long the job ID and then pipe that with grep of time, and you'd see like all of the attributes that has the time word in it. That way it would be easier for you to filter out the actual class add that would be useful. And also, yeah, the most useful thing to find out like whether it's the machine issue or is it a site issue or not, then you can use the command like the last remote host to see like where your job ran last. And also in terms of like, yeah, you can use the auto format command, and you can also add to the auto format command some options to make it easier for your viewing purposes. And I believe I have an example, and that will be coming shortly. And meanwhile, as I mentioned, this is probably we have answered when we are going through Joseph's question. Like Condor status gives you an idea about the pool, but not to assume that that's all the machines that we have. And also you can use some other flags apart from the log, like yeah, we have seen the auto format or AF flag, but you can also look for a set of jobs with the constant flag, or the not constant, with the constraint flag, the short for const, and you can filter out to look for, say, the jobs that are only on hold. And we have an example for this specific command, some slides afterwards. So let me come to the demo later. Let me just go through and show you the constraint or the const flag. So if you want to see all of the jobs that are on hold, yeah, so you can use the expression like control q -constraint job status equal to 5, and then you can grep for if you want to look for the last remote host, and we just give you a command that helps you in terms of probably getting an idea in terms of like, is it an issue with the site or it's like random. So in this case, the example that we have, and in that example, we could see like just a toy example here. This site, though it's all on the CHGC, this slot looks like all of your whole job, majority of your whole jobs are onto this site. So it gives you an idea, like probably this site may have some issues. And if you see those type of issues, I would say like, do get in touch with us and let us know, like, yeah, you are seeing this type of information, like your jobs are getting mostly hold in this site, then we'll check with the system admins of those sites and see like whether there's any known issues, or we can also give you the command to, if it's necessary, to avoid a certain site. And yeah, sorry for going back. Any questions overall? Like, this will be the end of the training. And if you don't have any questions, I'll just show you the demo portion that goes over like a contour queue better analyze example. Yes, Rahul, go ahead. You're muted, Rahul.
Hi, sorry, I just thought I'll share my video as well.
Yeah.
Yeah, so this is about let's say if the jobs are not even starting, so they're idle, and now so the question is, should I better constrain my job attributes so that I get more slots matched, or is it the pool or the OSG pool itself is doesn't have any resource, many slots available at that point? So it just because I'm new to OSG, I'm always, I don't know which of the two scenarios these would be. And just to give you some background, I'm using these scientific workflows. I think you might have heard of PyCBC. So this uses Pegasus at the back end, and it submits tens of thousands of jobs at an instant. So on our side, I think we have optimized it way better. And in the past, we have seen that we have managed to get, let's say, thousands of slots matched. But this has been, we have been observing that the slots that we get are now, the number is reducing. So yeah, I'm
And with the same requirements, like you are
exactly, yes.
Okay.
Yeah. So just to give you an example, at this moment, I have submitted about 10,000 jobs, and at best I'm able to get 20 or so slots. So um, also, yeah, I just wanted to know how many roughly the total number of slots are there available on OSG, just to get a better idea.
So the answer is actually very tricky. Like, it always depends on the type of resources that you ask for. And rule of thumb is the more resource requirements that you have, like easier answer would be like, if you are asking for, our system is designed to give you more lots of single core slots. If you're asking for multiple core slots, then yeah, definitely the slots would get more reduced. But at any point in time, it depends on to the pool. And as you're saying, like, you are not you didn't change any other requirements or resource requirement, but you're saying that drop in terms of pool's resources. And is it like you previously had, and priority would be an issue, but for your the way that you're describing, like from 1,000 to 20 or something like that, it shouldn't be priority won't be that bad, won't make the situation that bad. So Yeah, I don't have a good answer for you. Like, to my mind, it shouldn't, like, from 1,000 to 700, 800, that would be a more reasonable number at my head, like if you have run this one. So, and is it just today that you're saying, or like, is it something that you often see?
No, if I would say it would be like last few weeks.
Last few weeks.
Yeah, it's the situation is getting worse. Yeah, not sure if something is going on the OSG end or yeah, just
When you say that, to me, it sounds like something may be going on our end. But yeah, I'll let Andrew, Andrew, if you want to chime in.
I'll just, I guess I'm gonna go a bit more general here, but yeah, with the OSPool, as I mentioned earlier, it is a dynamic and somewhat complicated system. If it seems like it's been something that's been going on, if it's been going on for a couple of weeks, then that's probably not a transient issue. That's probably a systematic issue. Whether it's systematic on our side of the fence or on your side of the fence is another question. So something that we saw on our local system is we had upgraded our operating systems earlier in the year. And so folks who had been using the old operating system and they'd been specifying to use the old operating system found that after we upgraded our machines that, hey, they're not getting as many jobs running anymore. And because they hadn't updated their submit requirements to go along with the changes, they were seeing a reduction in throughput for their jobs. Now, while that's probably not the case in your particular situation, there may be similar things going on in principle where there's background changes to the system that for the most part shouldn't affect users, but maybe because of the particular requirements that you have or the nature of the job that you're submitting is seeing fewer slots. So, you know, this could be anything from, hey, we don't have as many multi-core slots available in the pool as we used to because maybe a major institution has changed their configurations, or maybe it is something to do with the operating system. So I would say specifically for you in the short term, maybe send us an email or visit our office hours and we can try and help get to the bottom of your current situation.
sure, that would be great. Thank you very much.
Yep.
Yeah, Joseph, go ahead.
I'd like to hear from Wayne, but I think it would be very helpful if Raul shared his screen and you walked him through better Condor Q, better analyze, and maybe reverse and see what's going on. I think we'd learn a lot from that, and not just because I'm in Lago too.
Yeah, sure. So let me do actually this one. So I'm already logged into AB20. So if you have access to any of our logging point, any of our access point, yeah, feel free to log in over there. And right now for this tutorial, I'm not using our notebook, but hopefully that shouldn't be an issue. So let me just do the git clone. So Christina has just created, sorry, not just created, she has a repo where we have some job info, like some jobs that are purposefully designed to not to finish, and we can use the Condor Qubit analyze. So I'm into that folder right now. If I do ls, so we'll have like two types of jobs, one job submit file, and sorry, two types of job submit file and just an executable and the logs folder. So the jobs that I'll submit will be the complex jobs.submit. And before I submit that, let me show you what does it look like. So this is purposefully created in a bad way, if that makes sense, like in terms of job submit file wise. Like we are submitting like 3 jobs from a single job submit file. And So the first job would take a longer time as the argument is 60, and this is, I believe this is just a sleep job. So it just invokes the sleep function. So very basic. And for the second job, we don't have a test.txt file, as you can see in this directory. So it would go on hold. And third job, 40 terabyte, there won't be any slot that would have 40 terabyte of memory. So it would always be in idle. And so let me submit this job, control submit, complex jobs.submit. And yeah, this is giving us a warning that this is a very bad way to do that. But yeah, it's just a warning message. And it submits 3 jobs. And if I do my control Q, press enter. Now I see that the 3 jobs are in idle, but at the very after some point we'll see like one of the jobs would go on running. I can watch that in live format, control watch Q. Hopefully when it would start, I'd see like one of the jobs would get on running, one of the jobs would go on hold, and the other one would be on idle. And for that specific job, I'll show you the command of control Q dash beta analyze. And let me see, hopefully that shouldn't be too long. And as it's taking some time, so I'll just walk you through what it should look like. My goal would be in this training to have a speak out a specific job, the job ID number, and I would do control Q this job ID dash beta analyze, and it will take some time, but at the end, it will show me an information that, yeah, so that what are the slots that it could find. So for this example, this is just 3 jobs. I see one of them has already gone on hold, one of them is an idle, and one of them is running. So let me exit from here, and I can do control underscore Q space dash no batch. And this is just 3 jobs, so I can easily know the job ID of the one that's in an idle side. But you can use the job status command to filter out among the 1,000 jobs if you just want to look for specific types of jobs. So right now, I'll just use control Q, the job ID, then space dash beta analyze, and I can use the short format, so that would work as well. And at the end, it gives you the information, but the main thing that I wanted to focus on was this one, the types of table. So it gives you like the architecture, yeah, it matches that many slot, the disk space, yes, but the memory, the target memory or the machine's memory that would be greater than our request memory, it found 0 slots. And over here, you can also see a summary that run analyzing of out of 4,808 slots on 2,000 something machine, all of the slots rejected by the job requirement. So in here, if you had a lower one, or I could do another one, let me see the one, what does it say? So this is the job that's actually is on hold. But in this jobs matchmaking, I could see like all the requirements that I had, there are many machines that could run. And in the summary side, I could see like 20 slots are rejected my jobs, but for their own requirements, yeah, this is the line that I'd like to focus. So this many slots are matching, but are serving other users. So for like GPUs or other high resources, you would get an idea like whether there's any slots or not. Even if your jobs are in idle, you should see some values like, yeah, that there are some machines out there, but these are serving other customers or other researchers are running the jobs on that. And it also gives you, yeah, how many slots are willing to run your jobs. Yeah. Oh, so yeah, this is very good. So it gives you that information like, yeah, these slots should match if trained. So if the jobs are finished, then yeah, this many slots should be able to run your calculation. So Joseph, I don't know whether it actually gives you serves the purpose, the question that you have, whether it gives you an answer or not. But this is the way that we usually actually advertise to our users.
I'm sorry, wasn't this job on hold? Oh, this job is on hold because of the transfer, but it would match. Got
Yeah.
it. Yep,
Yeah. The matchmaking would go through, then yeah, when it tried to attempt it, then it sees like, oh no, that it cannot find the files.
got it.
I'll just make a quick note that AC Condor team is tweaking the output of Better Analyze to hopefully be more understandable. And in fact, this may even be
I'm probably, yeah, this is
the
probably,
newer output, right?
yeah, this is probably a newer
Yeah.
one.
Yeah. Great, it's already out. Yeah, and then to go back to sort of Rahul and Joseph's question, when it comes to troubleshooting, like, hey, my throughput isn't as much as I expect, that is a bit difficult. That's just inherently challenging and something that it's hard for us to do kind of on the fly. And to further complicate this, Rahul, it looks